they bring it up, it gets worse. Now we had networking problems, we had CPU problems, we had everything. So then magically doors start opening and you go to places. So these kind of setups of data centers is not so weird.
Anything could happen.
Anything could happen, and to understand...
LLDP is like CDP.
It's like CDP, correct. And it's...
Neighbor discovery.
And then we fix it for them. We find that, we have engineering, update, manufacturing, and it ripples down to the...
And I can already hear all the haters from here that say, oh yeah, the product is not tested before it's released.
Welcome to Cisco Tech Stories, a podcast with real stories from real tech engineers. Your hosts are Nico and Tristan. In today's episode, what do you do if everything you do to fix an issue is actually making things worse? You go on site and walk in the footsteps of the field engineer.
Hello, our interviewee today is called Ramses. Ramses, I think you have quite some years of experience in Cisco and you've done a few technologies as well. Can you maybe introduce yourself?
Yeah, of course. So my name is Ramses. I work as a distinguished engineer in TAC at the moment. So I've been most of my career working in TAC, and I started actually in a team which we called in those days the NMS team, which was basically a team where we handled a lot of different management and monitoring applications. I always liked it because you basically do everything. You weren't doing routing or switching, or you weren't doing wireless. You were basically doing a wireless management solution, or you were doing a management application on optical gear. I liked it because it was everything and nothing. After that, honestly, I always started my career before Cisco in data center, and after 3-4 years, I started missing that. So I moved to the collaboration team, which was the most logical choice then, because actually it's the only place where they had a spot for me at that point in time, and I just needed something different.
It was not a real choice.
Well, yeah, I wanted something different, and there was something different over there. But my long-term goal was data center. So I was thinking, look, these voice guys, they're running on UCS servers. So I'm thinking, yeah, I'll do voice, but they actually need people helping on VMware and compute, so I'll do that as well. And then I really moved into the data center team. So I went to a storage team, I went to a compute team, then I started something we call DCN Solution, which was our team supporting things like FlexPod and VBox, all the integrated solutions we were selling. And I ended up in a team called the ACI team, which was at those days the latest, nicest controller as the end-driven approach to data center. So I had a lot of fun over there. So I would say still data center was a line through my career that I always did. Yet I tried to make the best of it in the teams where I was, let's say it like that.
Do I remember correctly, you were also identifying as a Linux guy early on rather than a networking guy?
Yeah, probably. I think I started at Cisco as a Linux guy, and that's why probably I landed in the NMS team, because they were doing SunOS. It was close to AIX and Linux, what I did before. So I think I always dragged that a bit with me, which is funny because now there's a lot of Linux people program on Python and all that stuff. But I remember when I joined here, Linux was something weird. SunOS was the thing to do, and Linux was what the guys did as a hobby in the weekend. But nobody really thought that was something serious and ever going to happen.
Okay. So, but now you're a distinguished engineer, right?
Yeah.
So how would you define your job is compared to a regular tech engineer? I mean, it's an evolution of it, right?
Yeah, look, in the end, it's still the same. The idea is that I solve customer problems, but probably the idea is that I don't do it for an individual customer anymore, but I try to do it across the data center portfolio. So, for example, we're very focused with the team that I'm in now in driving automation, some of our products, driving connectivity, driving serviceability in scale, and often long-term. Sometimes we drive serviceability. We work today to see it going in product in 2 years and to see an adoption by 4 years. So we try on a longer horizon to solve a lot of our customer adoption problems. And what I also do is I work as a bridge between engineering and TAC. So to, sometimes bring engineering concerns into our delivery of the support and vice versa to explain to engineering where our customers are struggling so they can actually help make a better product.
And there's a lot of smoothing of between engineering and support people, right? Because I think there's always two different perspectives. Developers think one way, people in contact with the customer think another way. We just need to find the compromise, right?
Yeah, and of course, a developer, and it's weird, but a developer in the end often doesn't know what a customer does with the product. The developer is asked, can you please program an OSPF function? He has no clue that in the end will be used in an interdata, in a multi-site connectivity between data centers or with peering or with going to hypervisors. They just program an OSPF function. So if you talk to them about serviceability, sometimes it's a challenge for them because that's not really what they do. So you need to find a way to translate the serviceability requirement we have from TAC into a real functional function that the developer needs to write, often not knowing in the end how it's going to be used. And actually, by the way, vice versa, engineering says, look, we designed the product like this, why are they not using it like that? And the truth is, look, customers will use it in the way that fits their purpose. I can give a good example. My wife, she works she handles mobility in a city. And think about it in a park. In a park, if you put a beautiful road, but it basically makes a 90-degree corner, and if people are walking, they won't take the corner. They won't go straight and then right. They'll go in an angle because they see the lawn and they can go over the lawn, so they go straight over the lawn. It's fairly similar with our products. A developer makes something, not necessarily that is the way how customers will use it. They find a way around it, or they find a way to fit their use case, and then we sometimes need to connect both parties together.
Okay, so what stories do you have for us today? Which technology first is it about?
Well, I first, because I was thinking, what are the really fun stuff that I had in my career? And I have a lot around product, but I was thinking, let's maybe talk about one thing I had in the past around a compute challenge that I had with one of my customers.
Let's go.
So a while ago in the past, I supported a product called UCS, and we're still selling it, and now I think we're selling M6 and M7s. But in those days, we were selling a server which was called the C460. And it was a really huge server, and we actually called it a Lego box because it had probably more than 100, 150 movable parts in it. And we could actually individually RMA them. So it was a really cool server if you would buy it separately because it was like a weekend of assembly. Luckily, you can order them assembled from Cisco.
It's like a la carte server, right? You would choose the
Yes, yeah. But it had 4 sockets, you could go unlimited memory. You could put 8 or 10 PCIe cards, huge amount of storage. It was a beast. And those servers were incredibly attractive due to the amount of CPU that could go in there and the amount of NICs. They were incredibly attracted to financial customers doing low-frequency trading. Because you need a large amount of computing power in a really small amount of rack space, because those customers are typically in very specific locations in data centers, close to financial peering locations. So they typically get one rack, and that's it. And they need to get everything in there. So with this, we had a customer, and they bought a rack of these servers, and they were doing high-frequency trading and high-frequency computing within that rack. And they had a server with a problem. That's how it all started. So they called in and they said, look, we have a Linux operating system, and sometimes it's just, we get the screen of that, the thing just crashes. Okay, good. So we get a call and we do the analysis, and with UCS servers, and it's actually with probably all compute vendors in the world, the instrumentation on a motherboard, it's always a trade-off between speed and what the motherboard can provide. For example, for all these vendors out there, you have nice CDs, ISOs that you can boot to do a bench test, to test memory and CPU, and that's very high computational stuff they do on it to see what's wrong. But while the system is running, they can't do too much of that. Think about it, you would almost have to say a bit, you would almost have to know the bit starts at the CPU, then goes through the bus, and at the end of the bus, you check again if the bit is still right. It's like CRCs on the buses.
It's like doing debug IP packet on a router. It's not practical in production.
No, it's not practical in production. And at the speed of a CPU, it's way too slow. So there's not that much instrumentation. Now, as a consequence of that, when you RMA, you kind of start typically with the memory, then the motherboard, and the CPU. it's a bit in the sequence of the cost, but it's also in the sequence of what's most highly likely to fail. Typically, memory DIMMs go first, then the motherboard, because, well, when you're manipulating memory, you touch the motherboard and there's a chance you break something. CPUs rarely fail, so they're the last thing we RMA.
And I guess if the CPU fails, it fails big time, right? It's less subtle.
Yeah, it's less subtle. It's much more harder crashes and things like that. So they were getting these kernel crashes, so we were like, okay, look, let's identify some of the DIMMs where we think there's a problem. We RMA the DIMMs, and the customer came back and it actually got worse. So we were thinking, look, that's strange. So we were thinking, look, we were in our normal modus operandi because no bells went off yet. So normal modus operandi, tech engineer, I was working with him on it and we said, okay, we go for the motherboard.
Wait, it happened only on one server, right?
Only one server. At that moment, one server, good. So we RMA the motherboard. So the motherboard RMA was a fairly extensive RMA because, as I said, it's a Lego box. So there's like 100 parts going out, new motherboard going in, all the parts going in, and we have field engineers that could handle that really well. So all went smooth. They bring it up, it gets worse. Now we had networking problems, we had CPU problems, we had everything. So we still do our normal modus operandi, but by that time, honestly, we really started very closely watching it, and we already had more calls internally. And we were saying, okay, look, we can try the CPU, but it starts looking really strange. So, and we had 4 sockets. So we said, look, okay, let's just RMA all the sockets. You never know. So we did all 4 of them. And this is the day when you still had to put your self-cooling past on CPUs. So it is, if you think...
You have to do it right.
You have to do it right. And we had field engineers that did it right. They really did it right.
But stupid question. Yeah. I mean, what about RMAing the whole box? Because right now you already spent a lot of man hours swapping all of that. You're saying swapping the CPU is a complex process. I know RMing the whole box is costly as well, but at some point, where's the...
Well, at some point you want to do that, but we were still thinking, we were only 2 days in, we were still thinking we can fix this. Mm-hmm. Because RMing the box means if we need to RMA the entire chassis, the entire box, it also means that it needs to come from manufacturing. Because the C460, like most of our servers, everything is individual fruable, so it means I cannot get a full config order from the warehouse. So that needs to come from from real ordering. If all the stars align, we can get that probably in 10 days into Europe at that location where it was. But we would normally not go for that immediately. It's a much more complex operation and it takes a lot more time. And we were thinking, we're going to solve this. So we sent 4 new CPUs on site. We RMA all the CPUs and it actually completely works. So we're thinking, look, we need to understand what's happening there.
And can you define worse? Like, how worse can it be if it's already crashing all the time?
It couldn't even boot anymore. Literally, there was nothing working on that thing. Lights wouldn't come up at the back of the server. Everything was a complete disaster. So yes, at that moment, we're saying, look, we're just going to RMA the server. But we were also thinking, we still don't understand the problem. So we can go and RMA the server, but for all you know, there's still something going on there. And then we can RMA all we want, nothing will be happening. So we won't be fixing anything. So yeah, we launched a parallel order with ordering, and the whole server was being RMA'd. But I also told my boss, look, I would like to go there and I would like to understand what's happening there, because I don't understand it, that every time we RMA something in that server, it gets worse. And I told him I'm scared because there's a lot more servers. If we RMA any of those servers, we might get the same problem. And we knew it was not a field engineer because we were sending different field engineers. And with each one of them, it started getting worse.
Can you comment maybe shortly on going on site? Because that's typically not something TAC does, right?
No, normally we don't. But, given, we're typically looking, if we have real systemic problems and we can't figure out what's happening, we might sometimes go on site because we need to understand it. And by the end of the story, you'll understand the only way to have solved this was going on site. I think that's sometimes just the case. So I flew to the customer. I launched an RMA to a random component in the server. It wasn't really that important. And I launched also an RMA with a field engineer. So field engineer would come and do the work. So the only thing I did was sit in the data center. So I was sitting there. I saw the field engineer coming. I saw the part coming. And I saw the field engineer not going to the data center, but he went to another room, a separate room. And I asked him, look, why are you going to this room, not to the data center? And he said, look, I'm not allowed to bring any packaging and any bags into the data center. So I'm thinking, yeah, that's reasonable. Yeah, that they run a good operation. So he unpacks everything, he takes it all with him.
Can you maybe just, without mentioning the customer, I think this was a financial institution, right? So extremely sensitive.
It was a financial institution, but the thing is, with low frequency trading, they're typically not in their own data centers in those days. They were a guest in another data center. So this was not a data center of that financial customer. This was a data center of a local stock exchange, let's say it like that. And they were allowing other financial institutions within them, so they're very close to their specific switch where all the trading is happening, because they're then really close to it, so they have much better access to, and nowadays that's a lot more regulated and there's a lot more things around it, but it used to be a bit different in the past. You could be in similar data centers. So the field engineer unpacks everything. Good. He's walking to the data center, and there was like a 50-meter walk we had to do to the data center, and it was a beautiful carpet. So he was walking over the carpet with the parts going into the room. And honestly, when he went into the room, he did everything right. ESDD charging, he had the thing, this wristband, the whole thing. But I soon realized, well, he has the components in his hands walking over the carpet. So basically, what he had in his hands was probably already, electronically fried before it actually ever entered the server. And he might, along the path, although he was doing all the ESD stuff, etc., well, he might have still, when he touched the server, maybe just before the wristband was on, he might have damaged even more. So yeah, every time we moved new parts into the server, it got worse, because every time we moved completely broken parts into the server, and also started damaging the server internally with more ESD charging. So our solution was for that customer more to ask if there could be a change in the procedure if we had to internally swap components, because you can't protect them that much if you put them in their hand, if those could be actually unpacked within the room, so that solutions were being put in place. But it's funny here that we had a server that was getting worse and worse and worse, and we could have done all we wanted, and we could have kept on RMAing, but it would have never been solved. They would have kept on walking over the carpet, and yeah.
The good thing is everyone was following the process, right?
Yes.
It was good training, but the process was just missing.
Yes, and you could now say, when you're listening to this, yes, but the field engineer should have known. Well, yes and no. It's highly unlikely that you would expect carpet in a data center, and it's something that we didn't, at that point in time, were telling our field engineers when they were swapping internal components to make sure do not walk on carpets. I think now those things have been, we made them more cautious about that, so they know, but in those days, yeah, that was a bit more new for us.
And just what could be a good solution? You said no packaging, but maybe it's tolerable to have those plastic bags, right? Like transparent plastic bags. That is ESD bag, right? That would be tolerable, right?
Well,
that would solve
at the initial point that we started, nothing was allowed into the room. So we couldn't bring ESD bags. We couldn't bring anything. Any packaging couldn't enter the room. So after that, yes, there was a deal made that different things could enter the room so we could protect the equipment. Yeah. But yeah, and unfortunately, he had the wrong shoes, because it depends on the shoes that you have and the clothes that you wear. Yeah, it was just the wrong setup for him. Even us, we're sitting on carpet here. You're not always very conscious about it. Carpet is in a lot of places, often in these kind of industrial buildings. And yeah, we were unlucky. That's it. But customer in the end was very happy. They also understood why the problem, they understood in the end that it was not a problem with our server, that it was more a problem with the environment. And they really appreciated us explaining that to them, because even that customer, you need to understand, it was a shared colo. They actually themselves had never been there. So they had never been there in that colo themselves. So they didn't even know that there was that kind of physical setup over there. So I think all parties in the end were very happy, but we could have only fixed it by going on site. Because only then could we have seen something obvious like that.
I think without being exactly the same situation, that happens a lot, where you think in your naive mind, you just go to your data center and you do this and it's easy, right? But then it's, but it goes through another partner and it's in another location, and there are third-party people involved that you're sometimes not aware of, and people don't see the problem with it. And it's one small detail in that process that is causing it,
Yeah. And I think, I've been a long time in the data center space for Cisco, and it's not so atypical. We have a lot of dark data centers, as we say, where there's no personnel, where our field engineers arrive in the middle of the night. They need to call a remote knock to type codes on a door. Then magically doors start opening and you go to places. So these kind of setups of data centers is not so weird.
Anything could happen.
Anything could happen. And often these customers don't really know what's happening over there. They have remote staff, they have remote hands, they have a third-party company installing the gear. So they just operate gear in there, but they're, with the entire, even now more and more with things like edge computing, where compute power is moved very closely to the users, it's often that people have equipment in places where they have not been that much in their whole life. Yeah.
And I think that's true in every technology group. In the enterprise as well, in the past you would have technical people pretty much everywhere, at least a small staff, and now there's a lot of branches without any technical personnel, etc. So you have procedures happening without anyone verifying how they actually happen.
Yeah. And it's with the best intentions. I'm very sure that the person who put the carpet there had the best intentions of keeping the building clean. And it was probably the best way to keep the building clean in that specific location, not knowing what the consequence would be. But yeah. We had a lot of fun, and I got a free trip to a place in Europe.
Nice. Okay, you have another story for us, I think.
Yeah, I had one more. It's so as I said, today I'm doing ACI. And actually together with two of my colleagues, Roland and Mio, we were involved really early on the product. So we were involved probably 9 to 12 months before, I think.
Can you maybe even explain very briefly for newbies what is ACI? Because not everyone knows what ACI is, I guess.
Yeah. So ACI is basically, think of it like you have a bunch of switches, 10, 20, 50, 100. And instead of configuring those switches individually, what you do is in a central location, in a controller, in those days we call it an SDN controller, in a controller you provision your network. But what is really nice about it is that you can define policies. I'll give you an example. There's a high chance if you have a data center with 100 switches, you probably will have 30, 40,000 ports. There's a high chance that those 20,000 servers connected to it then, because they all run a port channel, that they run a port channel with LACP. In classical switching, you would have to configure every LACP port channel individually. You would have to put the LACP options and things like that. So you would have to make sure that those 20,000 port channels are configured in the same way. You even might realize that, hey, because I configured that specific end host to it, I need to use those LACP options. You will have to identify of those 20,000 end hosts, which ones are that specific type of vendor. And then you need to modify maybe 6,000 port channels with that specific option. So what you do in ACI, you have a policy-based approach to the network where you basically say, well, this is my ESXi port channel. Maybe ESXi is 7.0 port channel. You configure all the options on it. And then on those 6,000 port channels, you link it to that one port channel policy. Which basically means I have one place to configure a port channel that impacts 6,000 port channels. Now, it's great power. That also means if you make a mistake in that one policy, it will propagate everywhere. But
that's the magic of automation.
Yes, that's the magic. And that's a detail because we never make mistakes. But it's nice. These controller-based approaches, they allow us to use shared policy, push it in large scale. And it also allows things like automatic upgrade of switches. And I know, Nicholas, you're a wireless guy, so for you that's normal. I plug in an AP and it auto upgrades because the controller sends it to it. Well, in networking, that was new. We didn't have this thing where a switch would come online and say, ask a controller, hey, what's the latest version I need to run, and then would auto upgrade. So 9-10 years ago, that was a new thing. So we put controllers in place to manage networking, and after that we had DINA coming as well on the enterprise side. So we really started putting controllers in networking. Yep. So when that came, we jumped on it, of course. We were data center guys. We saw this was coming. This was very exciting. So we were on it 6, 9, 12 months before Cisco officially released it. We were playing with it. So it also means we had a couple of, we call it EFT customers, early field trials, which were already practically live on the product. So we had a couple of really large customers. Now, some are already 100 switch deployments by the time we went live with the product. So from day zero of ACI, we had already a lot of customers in production running. Now, it also means that when TAC works with our engineering groups, we work really close with them and we work very early with them. and we also get products allocated to us. And that means when engineering makes a new hardware product, the tech support organization will get it a couple of months before it ships. So we can play with it, we can understand every ASIC in it, we can understand the installation procedure, everything we got. So that said, a couple of weeks before the product was actually being released, we got the controllers. We already had some controllers, but now we got the real official controller, how a customer ordering it would also receive it. And that's good for us because we could test it. So we put it in the lab, we boot it up, and we couldn't get a fabric to discover. So me or Alain, myself, we were all looking at it and we were trying and we couldn't get the fabric to initialize.
At that point, you had real customers running ACI already, but they had probably a prototype.
Yeah, correct.
And you had the final prototype, the release candidate hardware.
Yeah, correct.
Okay.
Yeah. So, and that was interesting. So we got the really fully configured APIC controller, which some of our EFT customers had as well, but they had a different build and a different software version. It looked and smelled the same, but the firmware on them was different for the customers. And that's typically how it goes before we release. And we take care of those customers in the end. They get all fixed to the right code. So we get a real official appliance, fabric can be discovered, and we start troubleshooting. And it was really weird. Even the three of us, we were on this product for 6-9 months. Engineering went on the call. Nobody could figure it out because we rely heavily on LLDP. So ACI will use LLDP. We use some TLVs in LLDP to understand.
LLDP is like CDP.
It's like CDP.
Cisco.
Correct. And it's
neighbor discovery.
Yeah, it's a neighbor discovery. And it's important because, of course, ACI, through LLDP, the API controller will discover the switch. Then they will do some initial DHCP, then send SSL certificates to each other, and they start encrypting their channels, and everything, communication will start. But if LLDP doesn't work, DHCP can't work, and everything else after it doesn't work.
Network is not discovered and nothing happens.
Nothing happens. But I was lucky, and myself, I was lucky, and me as well. We had a really good compute background. So we could clearly see on the APIC server, we could not receive LLDP. We couldn't see it. And we could also see that the switch was clearly sending it on the wire, but the switch was receiving nothing. And we could also see on the wire that the APIC was never sending it out. So we kind of knew it was the APIC because he would never send it out.
APIC is the server that provisions the controller.
Yeah, that's our controller. Yeah, that's our controller. So we knew it was a server, but it was funny because on the operating system we saw it going out, and on the wire it was never there. And that's weird because if we would sniff on the operating system, it was there. So you could, from the Linux perspective, it was there. From the VIC perspective, it was not there. When we put a sniffer on the wire, it was not there.
Okay, stupid question already. How do you put a sniffer on the wire? Was it like a fiber or?
Yeah, that was a 10 gig, and we had our lab teams. They have sniffers that we can put on there, and yeah, we can perfectly see what happens on the wire.
Already not trivial sniffing, but you had the equipment.
Yeah, we had the equipment over here because it's not a span. It's not like a span you could do. It's an in-wire sniffer. Yeah. So we put it on. We saw nothing was coming. So then, with our background of compute, we are thinking, but there's a VIC in there. It's a Cisco VIC. It means it's a smart VIC because it can make virtual things and it can do all kinds of features. So we go to the VIC, and there was actually a feature which I never realized we had on the VIC, and it was called LLDP. The VIC supported LLDP. And what it basically meant is when you enabled LLDP on the VIC would participate in LLDP. And we remembered on the switch, we saw some weird thing on LLDP announcing itself, and we never really understood what it was. And that's how it is in troubleshooting. It's easy afterwards to say, yeah, you could have seen it immediately. But yeah, at that point, we saw something weird doing LLDP, but it didn't look like the APIC, but we didn't have a clue what else it could be. So we saw that one option, LLDP, and we said, okay, let's just disable it. And we did, and it worked. So we went to our UCS engineering, and they said, yeah, that's an option. The VIC can be part of LLDP. Sometimes the operating systems don't support it, and it's nice for discovery because then you can do all kinds of things. So it's a great option, but not if you're on operating systems on top of it that know LLDP, because the VIC will filter everything out. It won't allow anything in, and it won't allow anything out because it is really doing LLDP.
It is literally blocking LLDP, but acting as a full network device.
Yeah, correct. Yeah. So then,
transparent.
Yeah. So then, we knew it was a really stupid option, and it's actually just a CIMC option that we had to push. So we worked with engineering, so they changed the CIMC configuration, so they could update that, and they could update manufacturing. But of course, we also had the challenge that a couple hundred controllers were already produced. They were in flight, they were shipping to customers. We had some already in the warehouses. So we had to stop ordering for a couple of weeks for manufacturing to pick up the new change. And then also for the next 2-3 months, well, we kind of knew where these AP controllers ship to. And, it was very controlled and availability of the product. So we were working with all the different sales teams to reach out to them saying, the AP controllers you got, they have that small flaw. Reach out to us when you start installation. We can really fast resolve it for the customer. So we did that as well. So I think probably still 6 to 12 months later, we were seeing cases of it and we were solving it. But we solved it as fast as we could when the product was being released. And I remembered, well, today is a VP, but my director over then, he said, look, you're the guy that stops products from shipping. And I said, look, I'm not proud of it, but but it's something it was for a good reason, And sometimes we have to do that. Actually, in TAC, sometimes we do see challenges with hardware products, which engineering might not necessarily have seen. And then we fix it for them. We find that we have engineering update manufacturing, and it ripples down to the
I can already hear all the haters from here that say, oh yeah, the product is not tested before it's released, right? It was actually thoroughly tested by many customers, but it just goes to say that a tiny change in a firmware can have huge effects, right?
Yeah, and that actually happens. So it's true, we had a lot of customers testing that product and using it in the field. But yeah, just before release, they changed the firmware code and they did all the testing. But you could only see it when you did a fully clean new discovery. And this was very early into the life cycle of that product. So most likely that specific QA workflow was not there. We're 9 years into the product now. That QA workflow is there by all means today. But yeah, we have never catched it. They try to do right by getting the latest firmware on the product. But one of those upgrades auto-enabled the LLDP system. And that's actually a bug we actually resolved with UCS as well, though, because it shouldn't auto-enable an option on upgrade. So there's a couple of follow-ups on that thing. But yeah, normally we do test as much as we can. And in this case, yeah, only a physical clean setup would have triggered it.
I think it highlights the complexity of the whole situation, because sometimes a product or release is delayed. People are frustrated because they were waiting for that product or release, but it's delayed for a good reason, right? So sometimes there are issues with it's not worth delaying the product or the release because that's a minor issue. Sometimes the decision has to be taken, no, we have to fix this. And we do a lot of testing, but any small change at the last minute can be impactful, right? You can never know to which extent it has ramifications. And
yeah, correct. And I think looking back, I think they did as much as they could, but that was a small oversight. I think the QA wasn't fully in progress then. They catched on really fast. I think this was very early into the life cycle of that product. And most of these customers were very much under control. We knew them very well. And it was a day zero issue. It was not a thing that brought a customer down. It was a thing that, well, you couldn't configure it. You couldn't deploy it. So from an impact, it was pretty fine.
Yeah. Okay. For closure, we do usually a small debunking question. I would like to hear from you. A question for me as a data center newbie. We've heard a lot of hype for the data center. People going, we need to have a large data center. The data center is everything in the enterprise. And then people are saying, no, everything back to the cloud. You don't need any data center anymore. You don't need anything anymore. And now that hype is a bit gone as well. And we're talking hybrid. And where's the truth? Where are people going?
Yeah, so look, for every workload, there is a specific place to run it. And what we see, for example, look, in the end, where you run things, inevitably it comes with a cost. Nobody runs a data center because they want to run a cool data center. Nobody runs in the cloud because they want to run in the cloud. They need to enable a business. They need to enable an outcome. And for that, they need to run some compute resources. But they are inevitably coming with a cost. What we are seeing with a lot of our customers is that they do like the concept of a cloud where they can really rapidly try things, where they can really get like 50, 100, 1,000 VMs spinned up, or use any kind of cloud construct that comes with it to really develop and test things. But as they scale, as they grow, there's a cost that comes with it. And then often an exercise is being made. Look, it might be that running that on-prem is actually a better cost exercise. So what we're seeing with a lot of our customers is that cost is a thing, and that's something that drives them to a specific location. And we see that on-prem data centers are still very attractive from a cost use case. Also, what we see is that a lot of customers are concerned about their data locality, where the data is, how a data center cloud provider can guarantee that. And that moves them into models like, for example, we call them today sovereign clouds, where they sometimes build their own clouds, where they use all the things that we like in the clouds, where you can nicely through APIs provision all kind of things, but they run it themselves on-prem on their own gear, which their own depreciation model, etc. So nowadays, I would say it's really more of an end-to-end model. Also, customers don't run on a single cloud anymore. They run on, if they run cloud, and then last week I was at a CAP, it's a customer advisory board where we have a lot of our customers. They asked the question, who only runs on one cloud? And some hands raised up. But when we started asking questions, who runs on 2, 3 different cloud vendors, a lot of the hands started going up. So customers really no longer run on a single cloud provider. They run multi-cloud because they're very aware of some of the risks of running on an individual cloud. And I think having their own data center where they either offload data, where they scale their things, where they put their sensitive data, where they can control of those, is still a modus operandi that we see more and more. So today it's a hybrid model, and it's a good opportunity for us to position some of our products around interconnecting on-prem data center with cloud providers and things like that. So Cisco has a big play in there. And I think within the data center, we're working more and more to have the concepts in place where you can consume your on-prem cloud, your on-prem data center, as if it's a real cloud environment. So API-driven, the application owner driving the consumption of it, not necessarily needing a full-blown data center team to provision a new subnet or things like that, fully API-driven and consuming it like that on-prem. And even myself, honestly, in Cisco, I witnessed that use case. I needed, Cisco has both internal and the cloud providers that provide services to us. And I needed a very high computational application. And when I got a pricing to run that in the cloud, or I thought, look, I just buy a server on-prem and I put it into one of the Cisco data centers, it was a factor ×5 to run it in the cloud. So depending if your workload...
More expensive in the cloud?
Yeah, 5 times more expensive because it's a very high computational workload we had, huge amount of I/O. Running that within a cloud provider that wasn't really suitable to run it. So running it on-prem made much more sense. We already had the data center, so getting a server into a data center made way more sense than running it like that.
And then the drawback of on-prem is that you need to manage it yourself, right? Here, because it was a project for you, like it was not a burden for you, right? That's what you mean. But then other people might want to say, oh, no, we want to offload that management and cloud is better.
Yeah, but the management, there are solutions if you run server solutions within your own data center.
Yeah, of course.
Even ourselves as Cisco, we have solutions for you to automate that management, to automate that firmware updates, to automate that networking, all these kind of things. So in the end, a cloud provider has servers and switches and routers, and there's firmwares and software running on it. It's just, a cloud is just somebody else's computer. But
just outsourcing your data center.
Yes, it's outsourcing your data center, but that comes with a cost. And I think a lot of people realize when they start running cloud providers, you will notice, and that, for example, in our data center space, there's an automation tool that's incredibly popular. It's called Terraform. It's incredibly popular because it can really very nicely deploy, but it can also undeploy resources in cloud. Because a cloud provider does everything they can for you to nicely to deploy, but to undeploy is always a challenge. They're in a business of providing things
better
to you.
If you keep paying, yeah?
It's better if you keep paying, of course, yeah. And I think, look, the reality is if you have high computational, high I/O intensive data, or you have some concerns around data privacy where you need to tightly control where the data lives, those are often reasons why customers opt to run within their own data centers and to run in some kind of hybrid model where they do development maybe in a cloud, but they run really in scale on-prem.
Thank you.
My pleasure.
That was very insightful.
Thank you.
Thanks for listening to this episode of Cisco Tech Stories podcast. We'd love to hear your feedback, so reach out to us on X at Cisco Tech Stories. Next time on Cisco Tech Stories.
So basically I get into the site, and at the moment I open the box, I don't see the connector or anything that it's in there. And I'm shocked, like, okay, nothing that I was supposed to do here would be possible. I called the BU and say, hey, I don't have this thing. They are surprised as well. Like, why don't we have this thing?